Imagine your software system as a bustling city, constantly generating reports about its activities. Suddenly, a strange pattern emerges in those reports: traffic jams where there were none, or a usually quiet district becoming unusually active. How do you spot these subtle, yet significant, deviations that could signal a problem? Detecting anomalies in log files primarily relies on methods that identify deviations from expected patterns. These methods can broadly be categorized into statistical techniques, rule-based approaches, and machine learning models. The goal is to flag events or sequences that are unusual, potentially indicating errors, security breaches, or performance bottlenecks. The core idea behind anomaly detection is to establish a baseline of normal behavior. For instance, statistical methods might calculate the average number of errors per minute or the typical duration of a process. Any data point that falls outside a statistically significant range from this baseline is considered an anomaly. This is important because it leverages quantitative analysis to find what a human eye might miss in vast amounts of data. To put these methods into practice, you often begin by collecting and parsing your log data, transforming it into a structured format that can be analyzed. With statistical methods, you might calculate metrics like mean, median, standard deviation, or apply moving averages to identify sudden spikes or drops in event counts. For rule-based systems, you would define specific patterns or thresholds that, if met, trigger an alert. Machine learning models, on the other hand, can learn these normal patterns from historical data and then predict what future behavior should look like, flagging anything that diverges significantly from that prediction. A key insight in this field is the concept of a normal system not being static. For example, some advanced machine learning techniques, specifically deep learning models like long short-term memory networks, or LSTM, are particularly good at understanding temporal sequences. This means they can learn not just what's normal now, but how normal behavior evolves over time, making them adept at spotting anomalies in dynamic systems where patterns change gradually. Other models, like isolation forests, are designed to isolate abnormal data points rather than profile normal ones, proving efficient for large datasets. Understanding these diverse methods for log file anomaly detection empowers you to build more resilient and responsive software systems. By proactively identifying and addressing unusual patterns, you move from reactively fixing problems to intelligently anticipating and preventing them, ensuring smoother operation and a better experience for users.
If this helps you fix faster, like, subscribe, and keep debugging with us.